In the previous videos, I introduced you to inheritance and the way Java supports inheritance with the use of the extends keyword. It's time now for a challenge to solidify your understanding of what inheritance is. For this challenge, I'm going to show you a class diagram like we worked with in previous videos. This describes what the challenge is all about in an image. This diagram starts with the worker class at the top of the hierarchy. This is the base or superclass. It shows one subclass, employee, but you could imagine other types of workers, perhaps contractors and interns, for example. From employee, I have two subclasses. These are salaried employee and hourly employee. Your challenge is to create the worker class, the employee class, and either the salaried employee or the hourly employee class. You don't have to do both, but if you want to, go right ahead. For each class, create the attributes and methods shown on this diagram. Note that employee has no methods of its own. Create a main method that will create either a salaried employee or hourly employee, and call the methods getAge, collectPay, and the method shown for the specific type of class you decide to implement. So if you implement salaried employee, then execute retire. If you implement hourly employee, then execute getDoublePay. See how you go completing this challenge? It will really help your understanding of what inheritance is. Pause the video now, and I'll see you back here where we can go over my solution. Okay, how did you get on? Did you figure it out? Bearing in mind there isn't only one answer to this, there is quite a few different ways to implement this. I've created an inheritance challenge project already, and I have the main class with a main method ready to go. Logically, I'd start at the top of the hierarchy, which is the most generic class or base class. This is our superclass, the worker class. My diagram identified at least three fields that a worker might have, namely name, birth date, and end date, which would represent the employment end date, private string name, private string birth date, protected string end date. I've made these fields private except for end date. The end date will get set by a method, either on this class or a subclass, so making it protected will give a subclass the flexibility to operate on it. Next, I'll create at least one constructor. I'll use IntelliJ's code generation for the name and birth date only. This mirrors a real-world scenario because when you are adding a new worker to your database, it's unlikely that you would know the end date. For that reason, I'm not going to include it here. And now you can see the first constructor. I also want to add a default constructor for the worker class, which gives my subclasses a little more flexibility. I'll type this manually, public worker. I could add getters and setters at this point, but I don't really need them for this challenge. Next, I'll add the necessary methods and generate a toString method for this class. Let's take another quick look at the worker class. We can see the methods we need to implement are getAge, collectPay, and terminate. Starting with getAge. This should return an int that represents the age of the person using the current year and the birth date, which is a string. Public int getAge int current year equals 2025. I'll using integer.parseInt to convert the year to an int from a substring of birth date, and I'll then return the value of subtracting birth year from current year. This code starts out by creating a local variable for the current year, which I arbitrarily set to 2025. I'm going to assume dates, birth date, hire date, and end date will be in the format mm/dd/yyyy. I'm using a method on string called substring to get the birth year and birth date. String has over 60 methods on it, and it's not really feasible to cover them in any single video, but eventually you'll see almost all of them as we progress through the course. Later in this section, though, I'll be looking at many of the most common ones when I cover strings and text blocks. For this method substring, I pass the start position of the string I want to extract, and since indices start with 0, the birth year starts at position 6. If I only pass the start position and not the end position, the string returned will be whatever is from the start position to the end of the string. Then, I use the integer wrappers parseInt method to turn a string into an integer, which I've done before. Lastly, I return the difference between the current year and the birth year to estimate age. That's the getAge method. I'll add the collectPay method. This will just return a double, representing the pay that will be received for a work period. I'll just return 0.0 for workers collect pay method. The method definition is public double collect pay, return 0.0. This method is the one that should be overridden by subclasses that can figure out the right pay to return based on the type of worker or other subclass. I'll add the last method, terminate, which is used to terminate employment. This will take a date and set the end date to that day. Public void terminate with the parameter of type string called end date. This .end date equals end date. This looks like a setter, doesn't it? I could have just created a setter, but creating a terminate method is a bit clearer for the business logic. In addition, subclasses might want to override it and add additional code that's specific to terminating employment for a certain type of worker. Finally, I'll generate the toString method for worker. I'll use all three fields. Okay, so that's my superclass. Next, I'll create the employee. Let's look at that class again. For this class, I have specific employee attributes, employee ID, and hire date. For simplicity's sake, I haven't included any methods specific to an employee, but you could probably think of some like get job review or take vacation, for example. I'll click New, Java class, and call it employee. When I create a new class, the cursor is positioned between the class name and the opening bracket, so I can just type in extends worker. I now have a subclass. You'll notice this time I don't get a compiler error like I did in a previous video the first time I used the extends keyword. This was because I created the default constructor for worker. So now Java can create a default constructor for employee with its own implied call to the empty constructor. I'll add my employee fields next. Private long employee ID, private string, hire date. I will generate the constructor with all fields. Notice this time that I can pick which constructor on the superclass will get called from this constructor. I'll pick the one with two fields, and I get the code shown on lines 6 through 10. You can see the call to superconstructor as the first statement in this constructor. You'll remember this has to be the first statement, otherwise I'll get a compiler error. This constructor has 4 fields, 2 fields that were declared by the worker class and 2 fields declared on the employee class. I'll add the toString method next. Remember to include the superclass toString method as well if it's not selected by default. And now I'll test the code I have so far. I'll open up the main.java file and add some code to the main method. Employee Tim equals new employee, and for arguments, I'll specify Tim, the 11th of November 1985, 77001, and the 1st of January 2020. Next, I'll use println to print the object Tim, which of course calls the toString method. I'll print age using a call to get age, and then do the same for pay using the result of calling collect pay, and running this code. I get Tim's information printed out when I pass the Tim instance to println. I've then printed out age, which was calculated to be 40 if the year is 2025 and the pay is 0. This is all good, but I will not pass employee ID on the constructor. I'll generate it. I can do this by setting a static field called employee number on employee. I'll set that to 1, so my first employee is employee 1. Private static int employee number equals 1. I'll simplify my constructor, removing the employee ID argument. And I'll set employee ID here, but using the static employee number field I just created. This dot employee ID equals employee dot employee number plus plus. Using the class name when using a static field helps people reading this code understand what's occurring. Notice here that I'm using the post increment operator, and now I've caused an error in the main method. So let's go back to that. I don't have to pass that 77001 now because my constructor is going to build an employee ID for me. I'll remove that. And if I run it, I get the same output except Tim's employee ID is 1. I'll just add another employee so you can see how the static field is working. Employee Joe equals new employee passing Joe, the 11th of November 1990 and the 3rd of March 2020. and I'll print Joe using println. And if I run that, check out the employee ID for Joe is 2. That's because employee number, that static field now, has the number of the next employee's employee number. Remember, a static field is a place that lets you share data among all your instances. When you're generating an ID for a new employee, it's a place to find the next ID to use. Okay, I'll end the challenge video here and pick it up in the next video. In this video, we created a worker class and an employee class that inherited from the worker. In the next video, I'm going to go a level deeper and create a specific type of employee.